geometric progression is what we refer to as GP progression. That's GP. So this is GP. This is GP. Now, the same way a arithmetic progression has sequence and series, same way also geometric progression also has sequence and series. That's the same way it occurs for this also. Now, what is this? What's the difference between geometric progression and arithmetic progression? The difference is that in arithmetic progression, we talk about common difference. But for geometric progression, we're talking about what we refer to as common ratio. We're talking about common ratio. So it means that for the progression of each of these terms, that is for sequence, is by multiplication. Now, for arithmetic progression, it is by addition, but for geometric progression, it is by multiplication. This is what I mean. Your first term, you have your formula to be Tn equals to AR n minus 1. This is for sequence. I'm explaining sequence now. Sequence of what? Of a geometric progression. This formula. What is A? A is the first term, as usual. R is common ratio. N is the number of terms, and then we have Tn to be equals to a particular term, to a term in the sequence. So that is the breakdown of everything that you see here. Now, how does this work? This is how it works. We said our first term should be what? A. If our first term is A, we said that for geometric progression, the difference between the first term and then the second term is that there is what we refer to as a common ratio, and geometric progression is what's working with multiplication. So if it's working with multiplication, therefore the next time is going to be A times R. Next one will be A times, you multiply the second term by another common ratio, because for you to get the preceding term, what you do is you multiply by the common ratio. That is how to get the preceding term that follows. So this is how we go. Then we multiply, we get to a point whereby we now have A times R n minus 1. Now we can see this is what? AR square. So it is moving. So we can see in the first term, this second term, this is the third term, and then proceed to AR n minus 1. So this is how we come about our formula for the sequence. Our formula for the sequence of a geometric progression. The sequence of a geometric progression. So let's check series of a geometric progression. How to get it. Series is also the same way as the other one, whereby we talk about the summation. Series is the summation. So for a series of geometric progression, we have what? Still the same. We can use S subscript n. This S is trying to tell us that we are dealing with series or summation. And then this is going to give us, we have this A open bracket 1 minus R to the power of n divided by 1 minus R. For R less than 1, and then we have Sn equals to A open bracket R raised by n minus 1 over R minus 1 for R greater than 1. Now, these conditions, and then we have what we call sum to infinity, and this is a over 1 minus r. Now I'm going to tell us the difference between the three. Now this is how it works. So the first thing, before you can sum or add things together in a geometric progression, before you can add them together, the first thing is that you need to consider the common ratio among them. Then how do you consider the common ratio? Common ratio is equals to the second term divided by first term. And it can be third term divided by the second term. Just make sure that it is the higher term divided by the preceding term that follows. So that's how to get your common ratio. Now after getting your common ratio, if your common ratio is less than 1, you make use of this formula to get the sum of your GP of that particular sequence. If your sum is greater than 1, that is, if it's 2, 3, 4, 5, 6, so things like that, then you make use of that. If it's a positive number, but majorly it's positive number, then you make use of this. Or if it's either a decimal or is in a fraction, or you have a negative number, things like that, then you make use of this number. And then we have what we call sum to infinity. We call it sum to infinity. So sum to infinity says that a divided by 1 minus r. So this is how sum to infinity is. So the question can give you 1 plus 2 plus 3 plus dot dot dot. That is, look for it to get to the last term that we haven't imagined of. That's the meaning of sum to infinity. So you can get sum to infinity with respect to this. Make use of this formula and get the sum to infinity. That is, when you add it, when it's going to infinity or when it is proceeding, what is the approximate thing that it can actually be, that the solution can be, and that's what we have as sum to infinity. So this is what we have under a geometric progression and an arithmetic progression for us. So we can do well to go through them once again, and once again, no matter how you want to go through it. Just make sure you have a full understanding. So in our next video, we'll be doing some examples on arithmetic progression and geometric progression for more explanation.